And now, let's do a baseball problem. A baseball player hits a baseball with an initial velocity of 103 feet per second at an angle of 41 degrees. A fence is 10 feet tall and is 300 feet away from home plate. Find the parametric equations that simulate the path motion of the ball. Okay, so for x equals, what we're going to do is we're going to start with our initial velocity. T cosine, and now our angle 41. For our y equals portion of the parametric equation, we're going to start with 103, the velocity, t, sine, angle, and now let's include gravity, minus 16t squared. Okay, there are our parametric equations. Now we can start solving some problems here. How long does it take the ball to reach the fence? That is horizontal distance. So we're going to take the horizontal portion of our parametric equation here. 103t cosine 41. Now listen, how long does it take? We don't know how long it takes, so we don't want to substitute anything for t here. We're solving for t, but we know we're trying to figure out how long does it take the ball to reach the fence. We know how far away the fence is. It told us right here. It's 300 feet away. So we're going to set this parametric equation equal to 300. And then in order to solve for t here, all we're going to have to do is divide both sides by 103 cosine 41. So t is going to equal, it's going to take whatever 300 over 103 cosine 41 is. So let's go to our calculators here. Now you're going to want to use the fraction symbol, alpha, y equals, enter. Make sure your numerator is 300 and your denominator is 103 cosine 41. To get 3.859. So it's going to take 3.859 seconds. How high is the ball at that time, and does it clear the fence? Now you have two options. You can take 3.859 and you can substitute it for t here and here, and then plug that into your graphing calculator and solve. What I recommend doing is learning how to use the y equals portion of your calculator here to solve this type of problem. So we would go to y equals, clear out any of your previous data. And now we want to enter this y equals portion of our parametric equation here. 103 x sine 41, close those parentheses, minus 16x squared. And let's graph it. Let's take a look at the graph. Sometime if our graph is a little funny looking, that lets us know we did something wrong. Okay, that looks to be about right. So we're trying to figure out where is the height of the ball at 3.859 seconds. So what we're going to do is we're going to hit second window and we're going to push 3.859, enter. And now, second graph. And it tells us how high it is. At 3.859 seconds, the ball is 22.498 feet above the ground. Does it clear the fence? Yes, it does, because the fence is 10 feet tall. Example D, suppose there is a wind blowing at 22 feet per second in the direction opposite the horizontal path of the ball. Find the new parametric equations, including the wind. Does the ball clear the fence now? So we're going to start with finding the new parametric equations, including the wind. Ultimately, we're solving for, does the ball clear the fence? But like I said, sorry to repeat this once more, but let's first find the new parametric equation, including the wind. Let me draw you a quick diagram. Here I have a coordinate plane. We're going to hit the ball this direction, and then it boop, hits the ground. Now, the wind is blowing in the opposite direction of the horizontal path of the ball. So the wind is blowing this direction here. That's the way the wind's blowing. So what we have is we have a terminal ray here. And if I do the angle of rotation from the positive x-axis all the way to my terminal ray, we have completed a 180-degree rotation. So the parametric equation, including the wind, well, we know the wind's blowing at 22 feet per second, so 22 t cosine 180 degrees. That's the parametric equation for the wind. Now, hear me say this. I think we are all comfortable with the fact that whenever we are dealing with gravity, that is going to impact the y equals portion of our parametric equation. Whenever we are dealing with wind, that is only going to impact the x equals portion of our parametric equation. So, like I said before, does the ball clear the fence now? That's what we are ultimately trying to solve for. Well, now that we are having to account for wind, we're going to take wind and we're going to add it to the horizontal distance of the ball. 3 cosine 1, and we're going to have to set this equal to, how far away is the fence? 300. Give me just a moment. I'm going to have to go adjust my shade in the room. That's better. Okay, continuing on. Now that we have our parametric equations here equal to the distance of the fence there, we can begin solving for t. Notice both of these parametric equations, or both of those terms, they have t involved. There's a t, there's a t. So let's factor out a t. Okay, we factored out the t. Now, in order to get t all by itself, all we have to do is divide both sides. I'm not going to write that all again. That's a lot. We're going to have to divide both sides by what we have in parentheses here. And if we do that, we'll get t equals whatever 300 over all that stuff in parentheses is. So let's plug that into our calculators now. Second, quit, go back to the main menu there. Alpha y equals enter. Make sure your numerator is 300. And your denominator is everything inside the parentheses. 2 cosine 180, those parentheses, plus 103 cosine 41, close parentheses, enter. Looks like now that we are dealing with wind, our answer is going to be 5.383 seconds. Okay. Find the new parametric equations, including the wind, and does the ball clear the fence? Now, well, now that we know that it takes 5.383 seconds to get to the fence, let's figure out if it's going to actually clear the fence. Now, reminder, we already input the y equals portion of our parametric equation into our calculator with this particular problem in mind. So we don't have to do that again. What we have to do is we just have to hit second window, and now let's input the new seconds that we're trying to solve for here. 5.383, enter, second graph. It looks like after we hit this baseball and it goes into the air for 5.383 seconds, now that we're including wind, it's going to be negative 99.88 feet below the ground. That is not possible. That is not going to happen. So no. It does not hit the fence this time. I'm sorry, it does not go over the fence this time. And lastly, example E. Don't stress too much about this one. This is something that we're going to cover in more detail the next class after this particular lesson. All you're having to do is you're having to set up a new equation. So let me give you an example. This problem that we've been working on, we're hitting a baseball, right? Well, if you've seen baseball, we actually hit the ball above the ground. You know, the ball's pitched to you and then you swing and the ball's above the ground. So realistically, the y equals portion of our parametric equation doesn't actually match what happens in baseball. The ball is not actually hit off the ground. That's usually golf. How would you adjust the equations to show the ball is hit when it is 3 feet off the ground? Well, the x equals portion of our parametric equation is going to be the same. It's still going to be 103t cosine 41. That height difference, that's going to impact the y equals portion of our parametric equation. That would be 103t sine 41 minus 16t squared. We're hitting it 3 feet off the ground, so just add 3. That's it. You're done. Bye-bye.